Okay, so what we want to do today, and I want to give you some time to work at the end too. We're gonna move forward just a little bit. We're gonna change what we did the last couple days. Instead of giving you the graph of a quadratic function in a form that's really easy to graph, like we've been doing, we're gonna look at a different form of a quadratic equation and try to come up with a graph from this. Now, this is different than what we've had in the past. If I gave you, like yesterday, I probably gave you a function like this, different one. What if we had something like -3 times the quantity x plus 2 squared plus 5? You guys can graph that. How would you go about it? Yeah, close up the Chromebooks, please. You got to be totally click and closed all the way. Everybody with me on this. So how would we graph that? What's our strategy? Okay, find the vertex, right? We're going to start with the vertex. Where's the vertex?
-2, 5.
-2, 5. Good. Because we can see that h is -2 and k is 5, right? So we know if the vertex is at -2, +5, that tells us where we start. And then how do we know what to do from there?
A.
Okay, a is -3. So we're going to take our parent graph for a x squared, and we're going to stretch it vertically by 3 and reflect it and flip it vertically, right? So that'd be an easy thing to do. If we wanted to go to, let's see, we wanted to go -2, +5, there's going to be our vertex, right? And instead of going like we normally would, going over 1 and up 1 to get to the next point, we're going to go over 1 and we're going to go up 1 times -3, right? That's all we do. What's 1 times -3?
-3.
-3. So we're going to go over 1 and down 1, 2, 3 to get to our second point. And so it's going to be a tall, skinny, flipped parabola, right? No big deal. This is harder though. This is tougher to do because we can't just look up there and say, the vertex is at -2, 5. Okay, what is this? Okay, if we look at quadratic functions, we didn't really know it, but we've been dealing with quadratic functions in this form, right? That looks real familiar to you. F of x equals a times the quantity x minus h squared plus k. This is called standard form, or a lot of times we'll call it vertex form instead. How come? I mean, for obvious reasons. Why is that vertex form?
You can find the vertex.
You can find the vertex. Yeah, the vertex is at hk, and there's an h and there's a k, right? So the 3 parameters that we use to dial in a parabola, we need 2 for a line, we need 3 for a parabola. The 3 numbers that we have to specify to graph any parabola in the universe, right, on a 2-dimensional plane. In this case, the 3 parameters are really useful. H and K determine the vertex, and A tells us what the vertical dilation is, right? So that's easy to deal with. Now we're moving to this other form. This other form looks like that. That's called general form, and that's not very useful for graphing. It's useful for other things. This is a preferred form. A lot of the stuff that we're going to do in the future, near future, more algebra-related stuff, this is going to be a great form to put the quadratic function in. But one of the things we're going to learn to do is to be able to go back and forth between those. So when this one's more useful, we'll put the function in this form. When this form is more useful, we'll put it in that form. Okay? We do a lot of that stuff in math in the future. This one is, written in terms of the parameters a, b, and c, which aren't very meaningful in terms of a graph. A is just the coefficient of x squared, b is the coefficient of x, and c is the constant. But do notice one thing here. The h and the k got traded for b and c, but what about those a's? They stayed. What do you think that tells us about the a in the general form equation? Gavin, what do you think? No, I know. Okay, well, take a look up here. If the a stays the same, the h and the k got traded. They got traded away, and instead we have a b and a c, but the a stayed the same. What do you think that tells us?
It's like multiplying. It's the same number.
It's the same thing. Yeah, the A, we kept the A because the A in both of these forms, whichever way we choose to write it, they mean the same thing. A is still going to be the vertical dilation factor, okay? But how are we going to do this? Well, there's a trick. Thankfully, there's a trick. There's a really, and later on in the class, I'll show you why this works. Well, we'll derive this formula later in the class, but for now, I'm just going to tell you. We need to practice some algebra first, though, to allow us to do this. Here's our trick. For now, I'll just give it to you, and you can remember it. Later on, we'll come back and justify it. We can always find the x-coordinate of the vertex by just using this little formula, negative b divided by 2a, where b and a are just going to be parameters from this form of the quadratic function. Right, so I can always come up with the number value for h, which is the x-coordinate of the vertex, and then for any function, if I want to find the y value, what do? If I want to find the y value that goes with an x value, what do I do for a function?
You solve.
What do you mean by that?
You solve x and then put that for the y.
So I'm going to evaluate the function, right? I'm going to plug in that value for x into the function and see what we get. Okay? So let's try this. Let's go to this example, right? One we just looked at. Okay, so first of all, that's in general form. It's not in vertex form. What are the values of a, b, and c?
A is -4.
Okay, good. A is -4. What's b?
24.
24, and c is,
-41.
okay, everybody see that? Right? Just the coefficient of x squared, coefficient of x, constant, okay? So we've got those. We can now use our formula and come up with h, right? Why don't you close that up, please? Thanks. So our formula, so h is equal to -b over 2a, so let's just plug that stuff in. What's b?
24.
So what's negative b?
-24.
-24 divided by 2 times, and you told me a is -4, right? So if I simplify that, multiply straight across, I get -24 over what?
8.
-8. Good. So negative over negative is positive. 24 over 8 is 3. So we know h equals 3, right? So there's the x-coordinate of the vertex. Now we just need the y-coordinate of the vertex. Well, here's my function, right? This, all I got to do is plug in the x value to find the y value. So k is going to equal f of h, and h is 3. So what's that going to give us? If I plug 3 in, every place I have an x, I'm going to replace that with a 3 in parentheses, right? So that's going to give me -4 times, trade in my x for a 3, so 3 squared, plus 24 times x, which is 3, minus 41, and then we just simplify that. Okay, so let's go through and get numbers. What's 3 squared?
9.
9 times -4?
-36.
-36. 24 times 3?
60 plus 12.
So what is that? 72. Okay, good. So plus 72 minus 41. So -36 and -41 is what? -77? So what's -77 plus 72? -5. So k equals -5. And that tells us that our vertex is located at the point 3, -5, and what's a? -4. That's all we need, right? If we have that information, it's really easy for us to come up with a graph. So let's do that. Okay, that guy right there. 1 second. Okay. So here it is. Right? So this is the function. There's the function we're graphing. -4x squared plus 24x minus 41. Well, we just found out that A was 3, -5. So there's that point, right? Or that, sorry, that H and K were. Let's compare this to our parent graph, right? The parent graph is just going to be a regular parent parabola with that vertex, right? So wouldn't that just look like our normal parent graph is going to go from the vertex, I would go over 1 and up 1, right? Everybody agree? Okay, so then the shape, here's our parent graph, would just look like that, right? Okay, so then, once again, put this in perspective. So we know for our parent graph, if we go, if we go horizontal distance of 1, we go a vertical distance of 1 squared, which is +1. Okay, what was our A again?
-4.
It was -4, right? So if we're going to go, we're going to multiply our vertical distance by -4. What's 1 times -4?
-4.
-4. Good, right? So we know that -4 times 1, oops, 1 equals -4. So we're going to, instead of going up by 1, we're going to go down by 4, right? So there's going to be our vertex, and we're going to go down by 4, which gives us that point. Everybody see that? Right? So we're going to, instead of going over 1 and up 1, over 1 and down 4, and then of course we're going to get the other reflected point on the other side. So if I just connect those with a parabola, we can see what our parabola looks like. Right? So this is the blue parabola. That's our graph, isn't it? Right? Yeah. Vertex at 3, -5, over 1, down 4. Right? No big deal. Okay. All right, let's look at one more of these. Okay, this one's a little tougher because it's got fractions. So what about this time? They're telling us to find the vertex. Okay, let's do one better than that. Let's find the vertex and let's do a quick sketch of this thing. Okay, so to find the vertex, this is in general form. So what's going to be the value of A? Luke, what's the value of A?
Value of A is 1/3.
1/3. Good. Lauren, what's the value of B?
1/8.
Almost.
-8/3.
-8/3. Okay. And what's the value of C? Kira, what's the value of C?
1/3.
1/3. Good. So we got A, B, and C. What is the formula, Noah, for finding H?
B over 2A
Almost.
multiplied by K.
Okay, -B
Negative B, yeah.
over 2A. Good. All right, so Kaylin, what am I going to plug in? Let's plug in our stuff here. This is going to look a little weird because we got fractions, but that's all right. We can deal with fractions. If B is -8/3, what's negative B?
8/3.
8/3. So on the top, we've got an 8/3. On the bottom, we've got 2 times A. What's A? 1/3.
1/3.
Okay, so now let's just kind of review this fraction stuff. What's 2 times 1/3? 2/3. How do we know that? Because there's an invisible 1 on the bottom of any whole number, any integer, right? You guys need to go. Yeah. So we multiply straight across, and that's just going to give me 2/3. Do I need to write that 1 there? No, not really. If I'm multiplying an integer or a whole number, are you doing the same thing? Yeah. If we multiply an integer times a whole number, we just know that we're multiplying by the top, right, by the numerator. So we end up with then 8/3 over 2/3, and that's our goal. Whenever we're trying to simplify a complex fraction, which means a fraction divided by a fraction, our goal is to turn the top into a single fraction and the bottom into a single fraction. Done. And then what do? What happens if you divide a fraction by a fraction? Remember? Sandy, you remember? No.
It's the reciprocal.
Yeah, what do you do with the bottom?
Flip it.
Flip and,
The denominator to the.
flip and multiply, right? So you're gonna, so we multiply the top by the reciprocal of the bottom. So just think of it as flipping and multiplying by the bottom. So we end up with 8/3 times
3/2.
3/2. And that's pretty convenient. 3 divided by 3 cancels. That's supposed to be a 3. And then what's 8/2?
4.
4. So h equals 4, right? All we gotta do is find k then, right? So to get k, what's our strategy for finding k?
Plug in.
Taylor Baum, what do we do to find k? If I found the x coordinate, how do I find the y coordinate? Right? Okay, so to find k, we're gonna plug in the x value into the function, right? So we're gonna get f of 4, right? Okay, so if we evaluate this function at 4, what's that gonna give us? So I get 1/3 times 4 squared, right? Minus 8/3 times, let's get rid of that, it's in the way. Eight thirds times x, what's x? 4, right? Plus 1/3. So let's just turn those into fractions. So what's 1/3 times 16? 16/3, yeah, because that's the same as 16/1, right? So that one's going to give us 16/3 minus 8/3 times 4. Same as 4/1. Multiply straight across. Minus, good, I heard it, 32/3 plus 1/3. Well, they actually worked out pretty well. All the denominators are 3. It won't always be that simple. What would have happened if this one would have been like 31/6? Say I had a 6 on the bottom. What would I have
By
to do?
2. No, wait.
No.
Multiply the other one by 2.
Multiply the other ones by 2/2, right? To get common denominators. Very good. Okay, so if I add these up, what's 16/3 minus 32/3? Negative 16/3 plus 1/3?
So that'll be negative.
Negative 15/3.
Well, can't you raise that?
We can. What's negative 15 divided by 3?
Believe it.
Haha. So we know what h and k are, right? Our vertex. There's a lot going on here.
That's a lot.
So hk is 4, negative 5. So that's our vertex. What's a?
1/3.
1/3. No big deal, right? So we're just going to vertically compress. We're going to multiply the horizontal distances by 1/3. We can do that. So 4, negative 5 is the vertex. Remember that. Let's go here. I got this. Uh-oh. Gotta turn those off. Okay, so there's, everybody agree that's our spot? 4, negative 5, that's our vertex?
Yeah.
Okay, so let's put our parent graph in. Normally, we would go over 1. Now, I picked these. How come? Normally, if we look at this, where's my pen?
Because 3 is a good multiple of 3.
Yeah, exactly. Okay, so normally, we would start at the vertex, and we would go over, we would go over by 1 and up by 1 squared, which is 1. We could go over 2 and up by 2 squared, which is 4. Or we could go over 3 and up by 3 squared, which is 9. Well, A is 1/3, right? So I want to multiply my vertical distances by 3. Remember, a vertical dilation, the points aren't moving horizontally, they're only being squeezed or stretched vertically, right? So I'm going to multiply my vertical distances by 1/3. Well, what's an easier thing to multiply 1/3 by?
3.
1 4, or 9?
9.
9, because 9 is a multiple of 3, right? So we're going to use this point. And if there's a point that's over 3 and up 9, there must also be a point that's back 3 and up 9, because it's a parabola, right? It's got symmetry. Okay, so there's our convenient points on the parent graph, right? And there's the graph. There's that distance. It's normally, right? We're going horizontally by 3 and vertically positive 9. What's 9 times 8? 9 times 1/3?
3.
3. Good. So 9 times 1/3 equals 3. So now we should only go up 3 instead of 9. So there's up 3. So that's where the, oops. So that's where my points are going to go. Look what we did. We took this whole thing and we squeezed it down. So this point right here is getting pushed down to there, right? That makes sense? So if we just connect the dots, we got it. There it is, right? There's our parabola. Okay? All right. Go to work. You got it. I want to see you do, on the new assignment, I'd like to see you do one problem from each of the 3 groups. Okay? Have at it.